So welcome to our new unit, which is 2D vectors, and it's the same stuff that we were doing in the last unit, except instead of just moving forwards and backwards or up and down, we can move up and forwards or back and down. So it's kind of like a Sonic the Hedgehog 2D world. So you need to know how to do trigonometry to do this unit. So you need to know Fagor Theorem, which is a squared plus b squared equals c squared, which you do in junior high, so most people are pretty good at that. But you learn this in grade 10 math, and it might be a little bit more rusty. So, ka, toa, where this is adjacent, this is opposite, and this is hypotenuse, if this is the angle that we're trying to find. So this is all on our data booklet. So if we just take a look under trigonometry and geometry, you have so, ka, toa, in case you ever forget it on a test. So I'm going to do a couple examples to refresh your memory. So I'm going to find theta here. So first thing you do when approached with a trig question is you write out so, ka, toa, and then figure out what you have. So we want to find this, and they give us the adjacent side, and they give us the hypotenuse side. So adjacent and hypotenuse is cos. And then you write out the formula. The formula is cos theta is equal to adjacent over hypotenuse. And it's just a formula. Just rearrange this formula. We want to isolate this, so we have to move cos down below. Right? And we could move cos down below, but that's not how we write it. Because if we move cos down below, it'd be 1 over cos. But another way of writing that is cos negative 1. So when we move it down below, we make it cos negative 1, but that's how we write it. So it's going to be cos negative 1 of our adjacent side, which is 4 meters, over our hypotenuse side, which is 7 meters. So in our calculator, we would make sure we are in degree mode, which I am, and then we would go second cos to get cos negative 1 of 4 over 7, and my answer is 55.15, so my angle is 55.15 degrees. Okay. And if I want to find this side here, well, I could use Pythagoras, but I feel like everyone's pretty good at Pythagoras, so I'm going to show you how to do this with SOHCAHTOA. Right, so this is the opposite side, and this is the adjacent side. We now know our angle, so let's use opposite and adjacent. So we'll write out the formula. Tan theta is equal to opposite over adjacent, like that. And we want to find the opposite side, so we rearrange by moving adjacent up there. So I go adjacent, which is 4 meters, tan of my angle, which is 55.15, and that's how I'd find my opposite side. So I type that into my calculator. So I would go 4 times tan of my answer from before, and I can find my other side, which is 5.74. So this is 5.74 meters. So let's get you guys to try some. So we have 3 here. So I want you to find y. I want you to find this angle, and I want you to find hypotenuse. So pause the video, try all 3 of them, and I will do them right now. So we have SOHCAHTOA. So for this one, we have opposite and hypotenuse. So opposite and hypotenuse is going to be sine. So we write out our formula. Sine theta equals opposite over hypotenuse, like that. And we want to find opposite, so we move hypotenuse up top. So my hypotenuse is 10 meters, and then sine of 20 degrees. So I pop that into my calculator. 10 times sine 20, and I get 3.4. We have 2 sig digs, 3.4 meters. Okay, for this one, I have opposite and adjacent, so I want to use tan. So we write out our formula. Tan theta is equal to opposite over adjacent. I want to solve for theta, so I move tan down below, or I call it tan negative 1. So I'd go tan negative 1 of opposite over adjacent. And my answer would be 38.65 with 2 sig digs, so 39 degrees. And this last one, we have adjacent and hypotenuse. Oh, look at that. So I set up my formula. Cos theta equals adjacent over hypotenuse. We're trying to find hypotenuse, so we need to move it to the top to start. And we just move cos theta down here. So it's going to be my adjacent, which is 24 newtons, divided by cos 50. So if I type that into my calculator, 24 divided by cos of 50, make sure you close your bracket, then you end up getting 3.37. We have 2 sig digs, so this is, I already forgot what it was. This is 37 newtons. And that's how you do trig, just like that. So what we need to know is how to communicate 2D vectors. So there's 3 different ways that we're going to learn. So the first way is cardinal, or sometimes I call it the physics way. Start with north, west, east, or south, and then state the direction and the angle your line is pointing from that starting position, which doesn't make a lot of sense, but when I do some examples, you'll be like, oh, okay, that's what's going on. So with this one, we just use north, east, south, and west. The second one is called bearing, and you start north and move clockwise. So that one looks like this, and we use degrees. So this is 0, we move clockwise this way. So this is going to be 90 degrees, 180 degrees, and 270 degrees. And then the last one is RCS, where you start east and move counterclockwise. And again, we use angles for this one. So this is 0, this is 90, because we move counterclockwise. And this is 180, and this is 270. So we'll just use this as a reference later if you're studying for this. So communicating 2D vectors, so let's do an example. So this is 30 degrees right here. And if we were doing it the cardinal way, we would go north, east, south, and west. Okay, so this is the way that I say it. I find saying it like this helps. It's touching the north, so I'm not going directly north, but I'm going 30 degrees east of north, and that's how we would write it, 30 degrees east of north. And when doing things cardinal, there's always a second way of doing it, because if this is 30 degrees, then this is going to be 60 degrees, right? And it's touching east, so I can say, well, I'm not going directly east, I'm going 60 degrees north of east. And when doing these, if you find it one way, all you have to do is 90 minus this number and swap these. So 90 minus 30 is 60, and east of north becomes north of east. When doing it RCS, let's switch up our color. RCS, this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. So you just start at 0 and you go counterclockwise until you hit your line. So I hit my line after 60 degrees, so this would be 60 degrees RCS. And then bearing is when we start up top and we do the same thing. So this is 0, this is 90, this is 180, and this is 270. So I start at 0 and I go clockwise until I hit my line, so this is 30 degrees bearing. Okay, we'll do another example here. So if we want to do this one, it's north, east, south, and west. So I'm not going directly west, this is where it's touching west, but I'm going 45 degrees south of west. So this is 45 degrees south of west. And then this one is also 45 degrees. So it's touching south, so I'm not going directly south. I'm going 45 degrees west of south. Okay, and then in terms of RCS, I switch out my color. This is 0, this is 90, this is 180. So I go 90 degrees, I go 180 degrees, then another 45, and then I hit my line. So that means that it is 225 degrees. And then bearing for this one's 0, this is 90, and this is 180. So I start at 0, I go clockwise, I go 90, I go another 180, and then 45 more. So this is also 225, and it's just this is the only place where it'll be the same. They just happen to be the same in this situation. So let's do a board question. So I want you to try these on your own, and I want you to communicate it those 3 different ways. Well, you can do it both cardinals ways, so 4 different ways technically. Okay, so pause the video and try it out. So north, east, south, and west, right? So this one's touching west. I'm not going directly west. I'm going 40 degrees north of west. So my first one would be 40 degrees north of west. And if I wanted to find my other cardinal, well, that would just be 90 minus this, which is 50 degrees. And I could change it to west of north. Okay. In terms of RCS, this is 0, this is 90, this is 180. And I know that this is 50 degrees here. So I go 90 plus another 50. So in RCS, this is going to be 140 degrees. I'm going to switch my color for bearing. So this is 0, this is 90, this is 180, and this is 270. So I go 90, I go 180, I go 270, plus another 40 would give us 310 degrees. Okay. So try this one, pause the video again, see if you can get it, and yeah. So in terms of cardinal, we have north, east, south, and west. Okay, so this angle here is touching south, so I'm not going directly south, I'm going 80 degrees east of south. And then this one is 10 degrees, so I'm not going east, I'm going 10 degrees south of east. In terms of RCS, this is 0, this is 90, 180, 270. So we go 0, we go 90, we go 180, we go 270, plus another 80, and 270 plus 80 is 350 degrees. Another way you could do this is 0 is also 360 degrees. So if you just go 10 less than 360, you could do it like that. And then bearing starts here, so this is 0, 90, 180. So I go 90 plus another 10, which makes it 100 degrees bearing. Okay, so there's some practice with that in your workbook as well. So what we can do now is we can draw velocity vectors. So if it says that my velocity vector 35 degrees, or 35 meters per second, 10 degrees east of south, I'm not going south, I'm going 10 degrees east of south. So this would be 10 degrees, and then the length of the arrow would represent 35 meters per second. So if I drew on another vector arrow, let me switch up the color for this. If I drew on another vector arrow, so RCS 120, so this is 0, this is 90, so it'd be another 30 degrees. So this would be 30 degrees, and I'd want to draw my arrow shorter. Oops, I drew it too long already. So let me erase that line. So because it's only 20, I want to draw a shorter arrow, and this is 20 meters per second. Okay. So now that we know how to communicate vectors, we can connect two vectors together by using tip-to-tail vector addition. So when you have two vectors, you can find out the resultant vector by using the tip-to-tail technique. All you have to do is stack your arrows tip to end or tip to tail, and the resultant vector is found by connecting start to end. So what I mean by that is, say I have two vectors. So someone is pushing on something with a speed of 10 meters per second east, and another person is pushing on 10 meters per second north. I don't want to connect them end to end like this. What I want to do is I want to stack them tip to tail, like that. So that's stacking them tip to tail. And then if I want to find the resultant, meaning if how is this object going to move? If a person's pushing at 10 meters per second east and another person's pushing at 10 meters per second north, how fast is it going to go and in which direction? So I can draw my resultant arrow in like that, okay? And I know that this is 10, so this is going to be 45 degrees, and this is north, east, south, and west. So I'm not going east, I'm going 45 degrees north of east. Okay, we'll do an example with it. So Mike walks 2 meters south, then walks 10 meters east. What is his total displacement? So we have to add these two vectors together. So what we need to do to start is draw a tip-tail vector addition. So I draw 2 meters south, and then I add that tip to tail 10 meters east, and I draw my 10-meter arrow longer. So this is my displacement here. This is what I'm looking for. So to find the magnitude of it, well, this is a side, this is a side, this is hypotenuse. So I just have to use Pythagoras. So a squared plus b squared equals c squared. So if I'm trying to find c squared, then I square root that like that. So I just go 2 meters squared plus 10 meters squared, all square root, and I can find out the length of that third side. So it's going to be 2 squared plus 10 squared. And then I square root my answer, and I get 10.19. Okay, so this is 10.19. Technically we have 1 sig dig, but whatever. 10.19 meters is fine. Now we also need an angle. So people always wonder, if this is my triangle, what angle do I find? Do I find this angle? Do I find this angle? Or do I find this angle? And my answer to that question is, you always find the angle that has no arrows on it. This has 2 arrows on it, this has 1 arrow on it. So this is the angle that we want to find. Okay, and then you draw in a little coordinate, north, east, south, and west. Right? So we're trying to find this right here, this one right here. So if we want to find this angle, well, we have opposite, and we have adjacent. So we can write out ka, toa. And if we have opposite and adjacent, we want to use tan. So we have tan theta is equal to opposite over adjacent. And I want to find theta, so I got to move tan. So I make it tan negative 1. And I'm ready to go. So if I tan negative 1 opposite, which is 10, over adjacent, which is 2, and type that into my calculator, I end up getting 79 degrees. So 79 degrees is not enough. I need to say it's 79 degrees, right? And this is north, east, south, and west. So I'm not going south, I'm going 79 degrees east of south. And that's how I would answer that question. So my displacement is 10.19 meters, 79 degrees east of south. So let's do a board question. Two tractors pull on a 12-kilogram tree stump. One pulls with a force of 830 newtons north, the other pulls with 450 newtons west. What is the net force on the stump? So give it a go. Try it on your own, pause the video, and I'll go through it right now. So first thing we need to do is draw a tip-to-tail vector addition. So one pulls with a force of 830 newtons north. So that's 830 newtons north. And the other one is 450 west. So I draw west. Okay. To find my net force, it's finding the hypotenuse side there. So to find the magnitude, we'd go a squared plus b squared equals c squared. So it's going to be 830 newtons squared plus 450 newtons squared, all square root. And we can find our resultant magnitude. So it's going to be 830, let's just try this again. 830 squared plus 450 squared. And we'll square root our answer. And we end up getting 944, and we have 3 sig digs in this question. So 944 newtons. Okay. And now what we need to do is we need to find this angle here, because this is the one with no arrows. So this is opposite and adjacent. So it's going to be TOA. Opposite and adjacent is tan, and that's what it will be most of the time. So tan theta is equal to opposite over adjacent. Move my tan over. So it's going to be tan -1 of opposite, which is 450, over 830. So I type that into my calculator. 450, over 830. And I get 28.5 degrees. And I need to put an angle in that, so I draw on north, east, south, and west. So I'm not going directly north, which it's touching. I'm going west of north. So west of north would be the answer. And that's how you'd answer that for full marks. Okay. One thing I should point out, what some people might do is they might draw it the other way. If you drew it the other way, you would draw 450 newtons that way, and then 830 newtons that way. And then this is your angle that you found right here. And if you tan -1 that, when you do opposite over adjacent, like that, you're going to end up getting 61.5 degrees. And it's going to be 61.5 degrees. Well, we're not going west, we're going north of west. And that's okay, right? 28.5 west of north is the same thing as that. Both answers are correct, and I will accept both answers. So you don't need to worry if you draw it the opposite way, you'll still get the right answer. There's a second part to this question which says, what is the acceleration of the tree stump? Okay, try it on your own, see if you can get it, and I will do it right now. So F net is equal to ma. And we already found F net, so if we just divide it by the mass, well, that's really easy, right? That's what we found for our question, was it was 944 newtons. So if we divide it by the 12 kilogram tree stump, we can find our acceleration really easy. So it's just 944, or I'll use my whole answer. 944 divided by 12. And we end up getting this as our acceleration. So 78.7 degrees, meters per second squared is our acceleration. And acceleration is a vector, so we need to include that 28.5 degrees west of north. So that would be our answer for our acceleration. So here's another example that we'll do together. Eric walks from point A to point B on the map below. What is his total distance and what is his total displacement? So distance is easy because, well, direction doesn't matter. So it looks like Eric walks 1, 2, 3 boxes up, then 1 box this way, 2 boxes down, 1, 2, 3, 4 boxes this way, and then 1 box up. So if we want to find Eric's distance, it's just 3, 4, 5, 6, 7, 8, 9, 10, 11. So Eric walks 11 boxes or units or whatever that is. Maybe it equals a kilometer, who knows, but he walks 11 boxes. Displacement is a little bit trickier, but what you need to know with displacement is when you have a whole bunch of vectors, you want to add them tip to tail, which this is already doing. And when you add them tip to tail, when you want to find the resultant displacement, you just have to go from start to finish, like that. A nice straight line from start to finish. And when we do it out on grid paper like this, what we find is that, oh, look at this, 1, 2, 3, 4, 5. So we go 5 this way, and then we go 2 up. So what we have is we have a nice right angle triangle, so we can find Eric's displacement. Now you don't need the grid paper to do that, right? If we go 3 up, 2 down, and 1 up, well, 3 minus 2 is 1, plus 1 is 2. Oh, look at that, just like there. And then we go 1 to the right, we go 4 to the right, 1 plus 4 is 5. So we can do that without the grid paper. The grid paper just gives us a nice visual. Okay, so all we have to do to find his displacement is 5 squared plus 2 squared, all square root. So 5 squared plus 2 squared, all square root. And we get 5.4 boxes. And then, oops, yes. And then to find our angle here, what we want to do is opposite over adjacent. So we'll tan -1, opposite over adjacent, 2 over 5. And when we do that, we end up getting 21.8 degrees. And we draw on our little coordinate here, north, east, southwest. So I'm not going directly east, I'm going north of east. And that would be our answer for our displacement. So let's do a board question here. Okay, so pause the video and see if you can do this. So half moose, half chicken walks all these directions. So we can use our grid paper. So we have 5 kilometers east, so 1, 2, 3, 4, 5. 4 south, 1, 2, 3, 4. 2 west, 1, 2. And then 3 south, 1, 2, 3. So we go from start to finish to find our displacement. And then to make a nice right angle triangle, this would just be 1, 2, 3, 4, 5, 6, 7 down. And 1, 2, 3 across. So 7 and 3. So I can finish this on the calculator. So just be 7 squared plus 3 squared, and square root that. That's our magnitude in kilometers. And then we want to tan -1 opposite over adjacent, so 3 over 7. Like that. So we have 23 degrees. And this angle right here is what we're finding. So we have north, east, south, and west. So it's touching the south. So we're not going south, we're going east of south. So this is 23 degrees east of south. So let's do one last example. So a car travels 120 kilometers west for 100 kilometers. It then turns north and travels 82 kilometers at 95 kilometers an hour. Calculate the magnitude of the car's average velocity. Okay, let's do that. So let's draw a little picture of what's happening. So the car travels west at a speed of 120 kilometers per hour, and it goes a distance of 100 kilometers. And then it turns north, and it goes at a speed of 82 kilometers per hour, and a distance of, oh no, 82, sorry, the speed is 95 kilometers an hour, and the distance is 82 kilometers. So if we find this, that's going to be some information. So the question is asking for the car's average velocity. And remember that we find our average velocity by our displacement total over our time total. So to find our displacement total, well, these are our two displacements, we could just go 100 squared plus 82 squared, all square root, right, our two distances, and we could find our displacement total. So let's do that first. So 100 squared plus 82 squared, square root our answer, and we get 129.32. So we'll keep that in there. So our displacement total is 129.32 kilometers. Okay, and our time total, well, we don't have times here, but we can use V equals D over T, right? Because we go a distance of 100 kilometers at 120 kilometers per hour, and then we go a distance of 82 kilometers at 95 kilometers per hour. Right, oops, I didn't rearrange this. That's why we're doing it like that. So we can find our 2 times. So let's do that. So the first one is 100 over 120. And the second one is 82 over 95, which is that. So all we need to do is we need to take our total displacement on top divided by our total time, which is going to be this time plus this time. So we add our 2 times up, and we get our velocity is 76 point, how many sig digs do we have? 2 sig digs. So 76 kilometers per hour is our average velocity, but it's a velocity, so it's a vector, so we also need to find an angle. So our angle is going to be here, so we just have to tan -1 opposite, which is 82, over adjacent, which is 100, because our direction would come from our displacement there. So if I go tan -1 of 82 over 100, I end up getting 39 degrees, and that 39 degrees north of west. So let's do one more board question. So Grumpy Cat walks 12 meters west in 40 seconds and lays down for 60 seconds and walks 8 meters south in 100 seconds. What is Grumpy Cat's average speed? So pause the video, try it. Rest in peace, Grumpy Cat. She was beautiful. Yeah, I hope you're all paused and you tried it and now you're trying it. Make sure you answer the question that I'm asking. I'm asking for average speed. And with speed, does direction matter? No. So to find our average speed, we just take our distance total over our time total. So our distance is going to be 12 meters plus 0 meters. Sorry, let me write that again. 12 meters plus 0 meters plus 8 meters. And our time is going to be 40 seconds plus 60 seconds plus 100 seconds. So if I do that and type that all in, well, this is a really easy question. 12 plus 8 divided by 40 plus 60 plus 100. So my average speed is, we have 2 sig digs, so 0.10 meters per second. That's it. Okay, make sure you answer the question that I'm asking. Lots of you probably found average velocity. Be careful of that on your test. Okay, this is our homework, not too much. So this is just practicing communicating those vectors. This is tip to tail stuff here, and these are those standard of excellence questions.